All right, I'm going to be reading page 78 in Exercise Physiology Theory and Application to Fitness and Performance. Powers, Halley, cha-ching. All right, page 78, Factors Governing Fuel Selection. It's one of my case study questions. I'm at the site, so I'm a site from here. All right. Proteins contribute less than 2% of substrate used during exercise of less than 1 hour's durations. However, the role of proteins as a fuel source may increase slightly during prolonged exercise, i.e. 3 to 5 hours duration. During this type of exercise, the total contribution of protein to the fuel supply may reach 5% to 10% during the final minutes of work. Therefore, proteins play only a minor role as a substrate during exercise, with fat and carbohydrates serving as the major source of energy during exercise in the healthy individual consuming a balanced diet. Whether fat or carbohydrate is the primary substrate during work is determined by several factors, including diet, the intensity and duration of exercise, and whether the subject is endurance trained. For example, high-fat, low-carbohydrate diets promote a high rate of fat metabolism. In regard to exercise intensity, low-intensity exercise relies primarily on fat as fuel, whereas carbohydrate is the primary energy source during high-intensity exercise. Fuel selection is also influenced by the duration of exercise. During low-intensity prolonged exercise, there is a progressive increase in the amount of fat oxidized by the working muscles. Endurance-trained athlete subjects use more fats and less carbohydrates than less fit subjects during prolonged exercise at the same intensity. In the next two sections, we discuss in detail the influence of exercise intensity and duration on fuel selection. The role of endurance training is discussed in detail in Chapter 13, and diet and performance is covered in Chapter 23. Alright, here it is. Exercise intensity and fuel selection. Again, fats are a primary fuel source for muscle during low-intensity exercise, i.e. 30% VO2 max, low intensity. Whereas carbohydrate is the dominant substrate during high-intensity exercise, i.e. 70% VO2 max. Consequently, the R increases as exercise intensity increases. The influence of exercise intensity on muscle fuel selection is illustrated in 4.11. Note! Alright, we're looking at 4.11 again. That's gotta be 4.11. Alright. Yep. What do you say? Alright. Let's see what they want us to note. Note that as exercise intensity increases, there is a progressive increase in carbohydrate metabolism and a decrease in fat metabolism. Also notice that as the exercise intensity increases, there is an exercise intensity at which the energy derived from carbohydrate exceeds that of fat. This work rate has been labeled the crossover point. That is, as the exercise intensity increases above the crossover point, a progressive shift occurs from fat to carbohydrate metabolism. What causes this shift from fat to carbohydrate metabolism as exercise intensity increases? Two primary factors are involved: recruitment of fast fibers and increasing blood levels of epinephrine. As exercise intensity increases, more and more fast muscle fibers are recruited. These fibers have an abundance of glycolytic enzymes, but few mitochondrial and lipolytic enzymes responsible for fat breakdown. In short, this means that fast fibers are better equipped to metabolize carbohydrates than fat. Therefore, the increased recruitment of fast fibers results in greater carbohydrate metabolism and less fat metabolism. A second factor that regulates carbohydrate metabolism during exercise is epinephrine. As exercise intensity increases, there is a progressive rise in blood levels of epinephrine. High levels of epinephrine increase phosphorylase activity, which causes an increase in muscle glycogen breakdown. This results in an increased rate of glycolysis and lactate production. Interestingly, there are some individuals who lack phosphorylase and cannot produce lactate. That could be either good or bad. We're about to find out. This increased production of lactate inhibits fat metabolism by reducing the availability of fat as a substrate. The lack of fat as a substrate for working muscles under these conditions dictates that Carbohydrates will be the primary fuel. See Chapter 5 for more details on how this occurs. Ooh. Many individuals use exercise as a means of keeping body weight and body fat in check. And you are probably familiar with pieces of exercise equipment having a selection for a fat-burning workout. In such a workout, the emphasis is on low intensity and long duration. But is that really the best way to burn fat? See a closer look at 4.2. We're not going to answer that today. We're going to answer that on the next video. Stay tuned. We're going to answer that next week. That is a huge question. I'm going to stop this video here and go on to page 79. So that was page 78. That's factors governing fuel selection. We'll go to page 79.